This video will be about problems 6 through 9 from the 2009 released Math OGT. Problem 6 says a virus measures 0.000022 millimeters in length. Which value expresses the length of the virus in scientific notation? So when you're doing scientific notation, you're basically trying to count from where the decimal starts to where you want the decimal to end. It must go in a particular spot. The decimal should always be after the first non-zero digit. We have a whole bunch of zeros, then we have a 2. We want the decimal to end right after that first 2. No matter what comes after, even this were 2237, we want the decimal immediately after the first non-zero number. So we're just going to count how many spaces would it take to get there. So 1, 2, 3, 4, 5. When you're going from a super small decimal, so left to right, that means we end up with that negative exponent of -5. Next problem. The net is folded to produce a three-dimensional object. Which object will this net produce? So a net is like a flat piece of paper where if we folded it and glued the edges together, it would make a three-dimensional object. So this corner would come up and be a top point of a pyramid. But really we just need to look at the shapes. It goes square, then circle, square, then circle. So if we look at A goes square, then circle, but B goes circle, then circle. So B is not our answer. A is our answer. C has that extra bottom part. We only have a base and these things that would fold up to be sides, these triangles on the pyramid. So we don't have anything underneath that base. And then D only has 3 triangles, but this has 4 on the net. Number 8, at the beginning of the day, the owner of a restaurant opens a new case of takeout boxes. One case holds 500 takeout boxes. He uses an average of 35 takeout boxes each day. So I'm highlighting some of the key words, how much he started with, that he's using them, and that there are 35 each day. Based on his average usage, which expression represents the number of takeout boxes that remain D days after the new case of boxes is open? So it said D days, and here is where the word day is in our keywords up here. So 35 has to go with the letter D. 35 was used every day, which means our answers can't be C or D because the D is placed with the 500. So both A and B start with 500, but then it says the word uses. Uses means this amount is going to be taken out or taken away, which means we need to use subtraction. So we look for those keywords to help us create our expression. Problem 9 is kind of a difficult one. It's a geometry problem where we're finding some area. The diagram shows a hexagon drawn inside of a rectangle. What is the area of the hexagon? So we want the area of this inside shape. Now, area of a hexagon is a pretty hard formula, and we don't want to use that if we can help it. Oops, I didn't mean to erase the problem. What we want to do is cut it into shapes that we do know the area of. We do know how to find area of a triangle. So you could take this entire top triangle. Another option is to take just one small inside triangle. Either way, there's some repetition. This top triangle is going to be the same amount as this bottom. So those two triangles would have the same area. Then we also have this rectangle. So once we cut it into shapes that we do know how to find the area of, we're going to find each shape's area. On a rectangle, the area is base times height. This is something you should memorize. There is a formula sheet, but I've heard it's not labeled super well. So memorize that the area of a rectangle is the base of the rectangle times the height of the rectangle. So the height is 3. That one's just placed on the outside edge. The base, we have to look and see if there are any lines parallel to it that would be the same. So this line here goes all the way from left to right, so it's the same length as this line that goes all the way from left to right. So that means our base is 6. So our area would be 6 multiplied by 3. You can do that in your head or with a calculator. 6 times 3 is 18. And I crossed out the 6 so we don't think it is still part of the area. We used it to find the area of 18. For a triangle, the area of a triangle is 1/2 times base times height. The way I remember this formula is if we took a rectangle and cut it in half, it makes a triangle. So 1/2 of your rectangle is a triangle, and that's where that 1/2 comes from. So 1/2 times base. Our base again is going all the way from left to right, so it'll be 6 times the height. This time the height of the triangle matches up with that left number here of 2. So to plug this in, to plug in the fraction 1/2, we do 1, but make sure on your calculator either to clear it out or to go to another line. So 1, AB will make a fraction, 2. Now we can't go times 6. If we do that, it's going to stay on the bottom. We don't want that times 6 on the bottom of the calculator. So I'm going to delete it using my keyboard. You click to the right of the 1/2 and then hit times 6 times 2. And I accidentally hit times 1. I have to correct that again. So 1/2 times 6 times 2 is 6. So the area of the triangle is 6. It happened to match the base. That doesn't always happen. It just happened in this case. So the bottom triangle is the same. It also has an area of 6. And now when you have a whole bunch of areas to make up an entire shape, we can add them together. 18 plus the 6 plus the 6 is 30. So the area of the hexagon is 30. And then you'll notice it says centimeters squared. Centimeters squared just means this is going to be an area. Square units is how we say, well, this is the flat space of what the shape takes up. So that completes our problems 6 through 9.